Welcome back to Dr. Finance. This is a paper written by Robert Solow, who won the Nobel Prize in Economics in 1987. This is what he published in Quarterly Journal of Economics 1956, titled A Contribution to the Theory of Economic Growth. Introduction. All theory depends on assumptions which are not quite true. That is what makes it theory. The art of successful theorizing is to make the inevitable simplifying assumptions in such a way that the final results are not very sensitive. A crucial assumption is one on which the conclusions do depend sensitively, and it is important that crucial assumptions be reasonably realistic. When the results of a theory seems to flow specifically from a special crucial assumption, then if the assumption is dubious, the results are suspect. I wish to argue that something like this is true of the Harrod-Domar model of economic growth. The characteristic and powerful conclusion of Harrod-Domar line of thought is that even for the long run, the economic system is at best balanced on a knife edge of equilibrium growth. Were the magnitudes of the key parameters, the savings ratio, the capital output ratio, the rate of increase of the labor force to slip ever so slightly from dead center, the consequence would be either growing unemployment or prolonged inflation. In Harrod's terms, the critical question of balance boils down to a comparison between the natural rate of growth, which depends, in the absence of technological change, on the increase of the labor force, and the warranted rate of growth, which depends on the saving and investing habits of household and firms. But this fundamental opposition of warranted and natural rates turns out in the end to flow from the crucial assumption that production takes place under conditions of fixed proportions. There is no possibility of substituting labor for capital in production. In this assumption, if this assumption is abandoned, the knife-edge notion of unstable balance seems to go with it. Indeed, it is hardly surprising that such a gross rigidity in one part of the system should entail lack of flexibility in another. A remarkable characteristic of the Harrod-Domar model is that it consistently studies long-run problems with the usual short-run tools. One usually thinks of the long run as the domain of the neoclassical analysis, the land of the margin. Instead, Harrod and Domar talk of the long run in terms of the multiplier, the accelerator, the capital coefficient. The bulk of this paper is devoted to a model of long-run growth which accepts all the Harrod-Domar assumptions except that of fixed proportions. Instead, I suppose that the single composite commodity is produced by labor and capital under the standard neoclassical conditions. The adaptation of the system to an exogenously given rate of increase of the labor force is worked out in some detail to see if the Harrod instability appears. The price-wage interest reactions play an important role in this neoclassical adjustment process, so they are analyzed too. Then some of the other rigid assumptions are relaxed slightly to see what qualitative changes result. Neutral technological change is allowed, and an interest elastic savings schedule. Finally, the consequences of certain more Keynesian relations and rigidities are briefly considered. A model of long-run growth. There is only one commodity output as a whole, whose rate of production is designated y of small t. Thus, we can speak unambiguously of the community's real income. Part of each constant's output is consumed and the rest is saved and invested. The fraction of output saved is a constant s, so that the rate of savings sy of t. The community's stock of capital, capital K of t, takes the form of an accumulation of the composite commodity. Net investment is then just the rate of increase of this capital stock, dk over dt, or k dot. So we have the basic identity at every instant of time. K dot should be equal to S times Y. Output is produced with the help of two factors of production, capital and labor, whose rate of input is L of t. Technological possibilities are represented by a production function y being equal to f of k and L. Output is to be understood as net output after making good the depreciation of capital. About production, all we will say at the moment is that it shows constant returns to scale. Hence, the production function is homogeneous of first degree. This amounts to assuming that there is no scarce, non-augmentable resource like land. Constant returns to scale seems the natural assumption to make in a theory of growth. The scarce land case would lead to decreasing returns to scale in capital and labor, and the model would become more Ricardian. Inserting 2 in 1, we get k dot being equal to S times f of k and L. This is one equation in two unknowns. One way to close the system would be to add a demand for labor equation. Marginal physical productivity of labor equals real wage rate, and the supply of labor equation. The latter could take the general form of making labor supply a function of the real wage, or more classically of putting the real wage equal to a conventional subsistence level. In any case, there would be three equations in the three unknowns, K, L, and real wage. Instead, we proceed more in the spirit of Harrod model. As a result of exogenous population growth, the labor force increases at the constant relative rate n. In the absence of technological change, n is Harrod's natural rate of growth. Thus, L of t should be equal to L sub 0 times e to the power of nt. In 3, big L stands for total employment. In 4, big L stands for the available supply of labor. By identifying the two, we are assuming that full employment is perpetually maintained. When we insert 4 in 3, we get k dot being equal to S times f of k and L sub 0 times e to the power of nt. We have the basic equation which determines the time path of capital accumulation. that must be followed if all available labor is to be employed. Alternatively, 4 can be looked at as a supply curve of labor. It says that the exponentially growing labor force is offered for employment completely inelastically. The labor supply curve is a vertical line which shifts to the right in time as the labor force grows according to 4. Then the real wage rate adjusts so that all available labor is employed, and the marginal productivity equation determines the wage rate which will actually rule. In summary, 5 is a differential equation in the single variable case t. Its solution gives the only time profile of the community's capital stack, which will fully employ the available labor. Once we know the time path of capital stack and that of the labor force, we can compute from the production function the corresponding time path of real output. The marginal productivity equation determines the time path of the real wage rate. There is also involved an assumption of full employment of the available stack of capital. At any point of time, the pre-existing stack of capital, the result of previous accumulation, is inelastically supplied. Hence, there is a similar marginal productivity equation for capital which determines the real rental per unit of time for the services of capital stock. The process can be viewed in this way. At any moment of time, the available labor supply is given by 4, and the available stack of capital is also a datum. Since the real return to factors will adjust to bring about full employment of labor and capital, we can use the production function 2 to find the current rate of output. Then the propensity to save tells us how much of net output will be saved and invested. Hence, we know the net accumulation of capital during the current period. Added to the already accumulated stock, this gives the capital available for the next period, and the whole process can be repeated. Then we go down to the last part, which is qualifications. Everything above in the neoclassical side of the coin is everything above is the neoclassical side of the coin. Most especially, it is full employment economics. In the dual aspect of equilibrium condition and frictionless competitive causal system, all the difficulties and rigidities which go into modern Keynesian income analysis have been shunted aside. It is not my contention that these problems don't exist, nor that they are of no significance in the long run. My purpose was to examine what might be called the tightrope view of economic growth, and to see where more flexible assumptions about production would lead a simple model. Underemployment and excess capacity, or their opposites, can still be attributed to any of the old causes of deficient or excess aggregate demand, but less readily to any deviation from a narrow balance. In this conclusion section, I want merely to mention some of the more elementary obstacles to full employment and indicate how they impinge on the neoclassical model. Rigid wages. This assumption about the supply of labor is just the reverse of the one made earlier. The real wages held at some arbitrary level, W bar over P. The level of employment must be such as to keep the marginal product of labor at this level. Since the marginal productivities depend only on the capital labor ratio, it follows that fixing the real wage fixes R at, say, R bar. Thus, K over L should be equal to R bar. Now, there is no point in using R as our variable, so we go back to 3, which in view of the last sentence becomes R bar times L dot, which is equal to S times F of R bar times L, comma L. Or L dot over L should be equal to S over R bar times F of R bar and 1. This says that employment will increase exponentially at the rate S over R bar times F of R bar and 1. If this rate falls short of N, the rate of growth of the labor force on employment will develop and increase. If S over R bar times big F of R bar and 1 is greater than N, labor shortage will be the outcome, and presumably the real wage will eventually become flexible upward. That what this boils down to is that if W bar over P corresponds to a capital labor ratio, that would normally tend to decrease, R dot being smaller than 0, R dot being negative, unemployment develops, and vice versa. In the diagrams, S over R bar times big F of R bar, comma 1 and 1 is just the slope of the ray from the origin to the S times F of R and 1 curve at R bar. If this slope is flatter than N, unemployment develops. If steeper, labor shortage develops. Liquidity preference. This is much too complicated a subject to be treated carefully here. Moreover, the paper by Tobin just mentioned contains a new and penetrating analysis of the dynamics connected with asset preference. I simply note here, however, crudely, the point of contact with the neoclassical model. Again, taking the general price level as constant, which is now an unnatural thing to do. The transaction demand for money will depend on real output Y, and the choice between holding cash and holding capital stock will depend on the real rental Q over P. With a given quantity of money, this provides a relation between big Y and Q over P, or essentially between K and L. For example, M bar being equal to Q of Y and Q over P, which is equal to Q of F of K and L and F sub K of K and L. Where now K represents capital in use. On the earlier assumption of full employment of labor via flexible wages, we can put L being equal to L sub 0 times e to the power of NT. and solve 15 for K of T, or employed capital equipment. From K of T and L, we can compute Y of T and hence total saving S times Y of T. But this represents net investment. Wealth not held as cash must be held as capital. The given initial stock of capital and the flow of investment determine the available capital stock, which can be compared with K of T to measure the excess supply or demand for the service of capital. In the famous trap case, where the demand for idle balances becomes infinitely elastic at some positive rate of interest, we have a rigid fact of price, which can be treated much as rigid wages were treated above. The result will be underutilization of capital if the interest rate becomes rigid somewhere above the level corresponding to the equilibrium capital labor ratio. But it is exactly here that the futility of trying to describe this situation in terms of a real neoclassical model becomes glaringly evident. Because now one can no longer bypass the direct leverage of monetary factors on real consumption and investment. When the issue is the allocation of asset holdings between cash and capital stock, the price of the composite commodity becomes an important variable, and there is no dodging the need for a monetary dynamics. Policy implications. This is hardly the place to discuss the bearing of the previous highly abstract analysis on the practical problem of economic stabilization. I have been deliberately as neoclassical as you can get. Some part of this rubs off on the policy side. It may take deliberate action to maintain full employment, but the multiplicity of routes to full employment via tax, expenditure, and monetary policies leaves the nation some leeway to choose whether it wants high employment with relatively heavy capital formation, low consumption, rapid growth, or the reverse, or some mixture. I do not mean to suggest that this kind of policy, for example, cheap money and a budget surplus, can be carried on without serious strains. But one of the advantages of this more flexible model of growth is that it provides a theoretical counterpart to these practical possibilities. Uncertainty, etc. No credible theory of investment can be built on the assumption of perfect foresight and arbitrage over time. There are only too many reasons why net investment should be at times insensitive to current changes in the real return to capital, at other times oversensitive. All these cobwebs and some others have been brushed aside throughout this essay. In the context, this is perhaps justifiable. Thanks for listening.